Good day, Math Tutor Edu's viewers. It's me, Arvin, catching you on another maths content. Okay, and if you're wondering what happened to my face, is apparently I'm here to teach some of the important topics regarding calculus. Okay, if you guys wondering what is calculus, apparently it is something that is more advanced than SPM level, guys. Okay, yes, you are correct. Now I'm officially starting my content based on higher level studies. Okay, and this will be the starting point, or this will be my very first video. Okay, I hope that you guys will be engaged with my videos and find this content useful. Okay, so I'm going to start with, of course, my favorite chapter, derivatives. Okay, which is the derivatives of trigonometric functions. Okay, so I'm not going to take you much time. Okay, since this topic is more towards formula based. Okay, I'm just going to explain briefly on what is the formulas and how you can able to apply in order for you to solve the derivatives problem. Okay, so let us begin. Okay, so from here, as you can see here, you have three sets of equation on the left hand side, and you have three set of equations here from the right hand side. Okay, I want you to remember the three side on the left hand side first. Okay, this is literally a main. Then you can ask me, so how about the right hand side? Actually, the right hand side also you need to memorize, but basically these three on the left hand side is the fundamentals. Okay, as for the right hand side, is just a derivation from the left hand side's trigonometric functions. Okay, so let us start. Okay, for the starting one, let's say if you are differentiating sine x, okay, you should be getting cos x. Okay, which means that your dy over dx or y prime will be equals to cosine x or cos x. Okay, so this is for the first formula. Okay, as for the second formula, okay, you have a function of cos x or cosine x. So when you differentiate it, so you should be getting negative sine x. Okay, so this will be the derivation from this cos x. Okay, so this is for the second trigonometric function. Okay, let us move on to the third one. Okay, d over dx tangent x, okay, or tan x. So when we differentiate this trigonometric function, you should be getting secant square x. Okay, by the way, there is an explanation that why when we differentiate tangent x, it will lead you to secant square x, guys. Okay, basically tangent x, when you break it, it will be sine x divided by cos x, and from there when you differentiate it, it will involve some of the calculations, and that's how it leads us to secant square x. Okay, so from here, just want to make it short. So from here you can just understood that when you differentiate tangent x, you should get secant square x. Okay, so this is for the left side formulas. Okay, as for the right side formulas, okay, it's pretty similar. When you differentiate cotangent x, okay, cotangent x is basically 1 over tangent x. Okay, if you guys don't know what is the special trigonometric function, cotangent x is 1 over tangent x, guys. Okay, when you differentiate this, you should be getting negative cosecant square x. Okay, so this is for the fourth trigonometric function. So moving on, when you differentiate cosecant x, okay, what is cosecant x? Okay, cosecant x is basically is just 1 over sine x. Okay, 1 over sine x is also equals to cosecant x. So which means when you differentiate cosecant x, you'll get equals to negative cosecant x cotangent x. So this is actually a multiplication of two trigonometric functions together. Okay, so for the last one, as you can see here, you have secant x. Okay, secant x is basically 1 over cosine x or cos x. Okay, so from here when you differentiate secant x, you should be getting equals to secant x tangent x. Okay, as you can see here, for this particular two formula, you can actually sense there is a pattern over here. There's a similar pattern as you can compare over here. Okay, secant square, secant square. Okay, somehow you can able to relate with tangent over here. Okay, and similar for the cotangent and cosecant. Okay, they are actually relatable to one and another. Okay, so I hope that is a little tip that you can able to use in order for you to help in order to solve the derivatives of trigonometric functions problems. Okay, so enough with the explanation, so let's jump into the exercise now. Okay, let us begin our exercise now. Okay, exercise. Okay, let us underline this. Okay, we try to use more colors. Okay, try to make it more interesting. Okay, now, unlike same colors, okay, we try to use different colors. Okay, so let us start with our very first example. Okay, with the easy one. So given that y is equals to x sine x. Okay, so from here I can tell that this is like one of the easiest trigonometric functions that you can possible have. Okay, so from here how are we going to solve this derivative? Okay, similar that what you have learned during your SPM levels or any other similar level studies. Okay, we're going to apply the products rule. Okay, so this x we're going to treat it as u. This whole thing sine x we're going to treat it as v. Okay, so by using products rule, okay, so from here the derivative of this function, so it will be y prime, but if you wish to write dy over dx also can. Okay, it is up to the students. Okay, if you wish to write y prime also can. Okay, so from here y prime is equals to, okay, so we're going to cross multiply. So how are we going to do it? Okay, very simple. U times with v prime plus with v times with u prime. Okay, or in this case u times with dv over dx plus with v times with du over dx. Okay, so let us start with letter u. Okay, so from here u, which in this case is x, okay, times with dv over dx, which means the differentiation of v with respect to x. So what we have in the v here is sine x. Okay, so you differentiate sine x, you get cos x. Okay, so from here plus, okay, now v's term. Okay, the whole sine x term you rewrite at your working here, plus with sine x, okay, x, I mean the u, differentiation of u with respect to x, in this case it will be 1. Okay, sine x times with 1. Okay, the 1 you can literally omit in your working, because sine x times with 1, it is understood that it is sine x, but for the sake of working, let me just write here 1. Okay, and then for your final answer you can just leave it like this. Okay, so this is technically your final answer. So let me underline the solution for the exercise 1. Okay, let us start a bit easy and then slowly we go into a bit difficult and more complex one. Okay, let us take a look at the next example. So for the next question, okay, let us take a look at this example where you have here y is equals to 3 over x plus with 5 sine x. Okay, slightly getting complicated, still consider easy, but the complexity is starting to increase. Okay, so here you have 3 over x plus with 5 sine x, and here you have a denominator where there are x at the below, I mean x in the denominator. So before you want to perform the derivative or differentiation, so it is important to bring up the index to the top. Okay, the denominator you bring it to the top, so it will be 3x to the power of negative 1. Okay, so we're going to bring this index to the top. So from here y will be equals to 3x to the power of negative 1 plus with 5 sine x. Okay, so once everything is done, you feel that okay, there is no longer a simplification or adjustment of the equation. Now you can proceed to perform the derivation. Okay, so let us perform the derivation. Okay, similar. Okay, I'm going to apply y prime. Okay, so from here negative 1 times with 3, similar guys, whatever you learn in SPM is just continues over here. Okay, similar concept, you bring it over to your higher level studies. Okay, so negative 1 times with 3 you get is negative 3. Okay, x to the power of negative 2. Okay, I decided to do this step by step for your learning purpose guys. Okay, plus with 5, okay, times with cos x. Okay, you differentiate sin x, you get cos x. Okay, so from here we rearrange this equation, so it will be y prime is equals to negative 3 over x square plus with 5 cos x. Okay, so far so good. So let me underline the second solution of the example. Okay, so now let us move on to the third example. Okay, don't worry, I will give you more examples. Okay, for me, if you ask me that, more example is better. Okay, because rather than if I give you just lecture videos and then give you 1-2 examples, it's not good, you know. Even for higher level studies, especially higher level studies, you need more practice. Okay, for the next example, let's say a question give you, for example, y is equals to tangent x sin x. Okay, so now getting a bit tricky but still can solve. Okay, now you have two trigonometric function being multiplied together, which is in this case tangent x and sin x. Okay, so let us perform the derivative. Okay, so in this case I'm going to use dy over dx. Then you can ask me, can I use y prime? Also can, it is up to you. Okay, so from here dy over dx. Okay, similar concept of products rule. Okay, so I'm going to treat this as u, tangent x as u, v as sin x. Okay, so let us start with u. Okay, so I'm going to copy down the tangent x over here. So tangent x, okay, times with sin x. So you differentiate sin, you get cos. Okay, and then okay, you plus with, so you keep the sine function over here, and then you differentiate tangent x. So from here, when you differentiate tangent, you get secant square x. Okay, so let us proceed to the next step. Okay, so from here dy over dx. Okay, for the next step you need to be slightly careful because tangent x and cos x is a bit related guys. Okay, let me remind you again if you don't know what is the relation. Okay, as tangent x is also equals to sin x divided with cos x. Okay, so if you don't know, now it's a time for you to recall your basics of the trigonometric functions. Okay, so this is the basic of the relation of tangent x. So how you get tangent x is equal to sin x divided with cosine x. Okay, and here you have cosine x, so you can perform some simplification over here. Okay, so that's why I want to remind you, make sure you master the basic. Okay, let me erase this. Okay, so from here tangent x, so I'm going to break it down as sin x divided with cos x. Okay, and then times with cos x. Okay, plus with sin times with secant square x. Okay, so this cosine x and cosine x will cancel off, so here become 1, here become 1. Okay, so for the next step dy over dx. it will be equals to sine x, okay, sine x plus with sine times with secant square x. Okay, so as you notice over here, okay, by the way, before I forget, here you should have a sine x function. Okay, sine x. Okay, so up until now I hope you understand the working. Okay, so dy over dx is equal to sine x plus with sine x times with secant square x. So we still have one more step left. So what we're going to do now is we're going to factor out the sine x. Okay, so let us factor out the sine x. Okay, so from here your next step, dy over dx is equals to, so sine x you factor out, so you get 1 plus with secant square x. So this is your final answer for example 3. Okay, so let me underline the solution for example 3. Okay, so let me just repeat quickly on what we have done for example 3. Okay, example 3, similar case, we have applied the products rule, everything, and then from here we break down tangent x as sine x divided with cos x. We perform some simplification and then we factor out the sine x. So that's how we get the answer over here for question number 3. Okay, so let us proceed another example. Okay, so from here, given that y is equals to cos x times with 1 plus with sine x. Okay, so let me underline this. Okay, this fraction line. Okay, so it's slightly getting tricky, as in this case we're going to apply the quotient rule. Okay, so whatever you learn in SPM, just similar case over here. Okay, you will apply over here for your highest level. So make sure you master your basics, guys. Okay, so for this question we're going to use y prime. Okay, let me label this as u and the denominator as v. Okay, so let me quickly recap for the formula. So y prime is equals to v u prime minus u v prime divided with v square. Okay, so let me box this. So from here y will be equals to, okay, start with v 1 plus sine x. Okay, so let us do this step by step so that you won't get missed out. So 1 plus sine x, okay, and then times with the derivative of cos x. So you differentiate cos x, what you're going to get? Negative sine x. Okay, and then minus with u. In this case the u is cosine x. Okay, and then times with the differentiation of 1 plus sine x. So in this case is cos x. Differentiate 1, you get 0. You differentiate sine, you get cos. So you only here right here cos x. Okay, then you divide with 1 plus sine x squared. Okay, so from here let us continue. Okay, y prime. Okay, so from here your y prime will be equals to, okay, so 1 plus sine x times with negative sine x will be negative sine x minus sine square x minus cos square x, okay, and then divide with 1 plus sine x in bracket square. Okay, so are we good? So I'm sure you understand the working up until now. Okay, here it's going to get a bit tricky over here. So what I'm going to do is I'm going to factor out the negative over here. There is a reason, because later on there is a relation between sine square x and cos square x, which is actually equals to 1. Okay, so what I'm going to do in the upcoming step, so I'm going to factor out the negative symbol, okay, and then I'm going to substitute sine square x plus with cos square x is equals to 1. Okay, remember the basic trigonometric identities, okay, the formulas. Okay, so you're going to apply over here. Okay, but don't worry, I'm going to recall it in the working here again. So y prime will be equals to negative sine x, okay, minus, okay, factor out sine square x plus cos square x, okay, and divide with 1 plus sine x square. Okay, so let me recall that sine square x plus cos square x you should be getting equals to 1. Okay, sine square x plus cos square x is actually equals to 1. Okay, so from here, so let us substitute this as 1 in our working. So from here, y prime will be equals to negative sine x minus 1, okay, and then you divide with 1 plus sine x square. Okay, if you think this is the final answer, actually there's still a bit more adjustment we need to make on these equations. Okay, so let us adjust a bit more. Okay, y prime is equals to, so what I'm going to do now is I'm going to make the numerator and the denominator, their coefficient is similar. Okay, so from here I'm going to factor out the negative, okay, which inside here you are left with sine x plus 1. Okay, and then you divide with 1 plus sine x square. Basically sine x plus 1 is also same as 1 plus sine x, right? Okay, they are just the same. So what I'm going to do here, for your convenience, I'm just going to flip the position. Okay, I'm just going to change their position. Okay, 1 plus sine x. Okay, since they are similar, okay, only the difference is in the denominator you have power 2. Okay, so from here I'm going to factor out. Okay, simplify, here you are left with 1. Okay, and then the power 2 reduced to 1. Okay, so from here, okay, we are very close to our final answer. So from here your y prime will be equals to negative 1. Okay, and then you divide with 1 plus with sine x. So this is your final answer for example 4. Okay, let me underline the solution as well. Oops. Okay, so that is all. Okay, for now I'm going to stop until here. Okay, in future I will discuss more examples. Okay, if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming math content in the future. Okay, not at maths, guys. Okay, usually I will say at maths, but in this case, since we are taking the leap, so it will be maths content. Okay, so thank you everyone, and I'll see you in another video. Bye.